Imagine the brain as a bustling metropolis that never sleeps, constantly processing thoughts, feelings, memories, movements, and more. Just like any thriving city, it needs a steady supply of energy and resources to keep everything running smoothly, and that's where cerebral circulation comes in, the intricate network of highways and byways that ensures your brain gets the oxygen and nutrients it needs while removing waste products. Today, let's dive into the fascinating journey of blood through the brain. Cerebral circulation is all about delivering blood to and from the brain. It's responsible for keeping our brain cells alive and functioning by providing them with oxygen and nutrients while simultaneously removing carbon dioxide and waste. Without this critical supply line, our brain would quickly start to shut down, leading to serious consequences like strokes, seizures, and even coma. Just like all major roads lead out of a central city hub, the blood supply to the brain starts with the aorta, the main artery leaving the heart. As blood flows out of the heart's left ventricle, it travels through the aorta, which quickly branches into smaller highways called arteries. The first exit is the brachiocephalic artery, which further splits into the right subclavian artery and the right common carotid artery. Moving down the aorta, we also find the left common carotid artery and the left subclavian artery. These arteries are the main routes that blood takes on its way to the brain. Because the brain is such a vital organ, it has a safety feature, a dual circulation system, like having two separate power grids to ensure the lights never go out. The first is the anterior circulation, supplied by the carotid arteries, and the second is the posterior circulation, supplied by the vertebral arteries. These two systems meet up to form the circle of Willis, an important junction that acts like a roundabout, ensuring blood flow continues even if one path is blocked. Let's start with the anterior circulation. It all begins with the common carotid artery, which splits into the internal and external carotid arteries in the neck. The internal carotid artery is the one that's responsible for supplying blood to the brain, and it enters through a tunnel in the skull called the carotid canal. Once inside the cranial cavity, it gives rise to two major branches, the middle cerebral artery and the anterior cerebral artery. The middle cerebral artery acts like a supply truck, delivering blood to the temporal and parietal lobes, while the anterior cerebral artery delivers to the midline, frontal, and superior parietal lobes. These two arteries form the anterior section of the circle of Willis, connected by a short road known as the anterior communicating artery. Next, we have the posterior circulation. Blood from the posterior circulation comes from the vertebral arteries, which travel up through small tunnels in the cervical vertebrae and into the brain through the foramen magnum. These two vertebral arteries eventually unite to form the basilar artery, which acts as a central highway running up the brainstem. On its journey, the basilar artery branches out, giving rise to the posterior inferior cerebellar arteries, PK, supplying the cerebellum and medulla, as well as the anterior inferior cerebellar arteries, AICA, which nourish the lateral pons and parts of the cerebellum. As it continues, the basilar artery gives off smaller branches called pontine arteries that feed the midpons. Finally, it splits into the right and left posterior cerebral arteries, which supply blood to the occipital lobes, crucial for processing vision. The posterior cerebral arteries then connect to the internal carotid arteries via the posterior communicating arteries, completing the circle of Willis. The circle of Willis is like the grand roundabout at the center of a city, ensuring that blood flow can be rerouted in case of any blockages. This network of interconnected arteries offers multiple pathways for blood to reach the brain, safeguarding it from potential interruptions in blood supply. It's a prime example of the body's built-in fail-safe mechanisms. After delivering oxygen and nutrients, the blood's journey isn't over. It still needs to carry away waste products and carbon dioxide. Venous drainage begins with tiny veins on the surface of the brain that empty into larger channels called dural sinuses, located between the two layers of the dura mater. The superior sagittal sinus runs along the top of the brain, collecting blood and cerebrospinal fluid as it flows toward the back. This is where it meets up with the straight sinus and occipital sinuses at a junction known as the confluence of sinuses, like several rivers merging at a delta. From here, blood flows into the transverse sinuses, then down into the sigmoid sinuses before finally draining into the jugular veins, which carry it back to the heart to complete the cycle. Alright, let's recap. Cerebral circulation is all about maintaining the flow of blood to and from the brain, ensuring a constant supply of oxygen and nutrients while clearing away waste, the brain's dual circulation, with the anterior system from the internal carotid arteries and the posterior system from the vertebral arteries forms the circle of Willis, providing a safety net against blood supply disruptions. After nourishing the brain, blood drains through the dural sinuses and into the jugular veins, completing its journey back to the heart. Thanks to this intricate circulation system, our brain stays healthy, allowing us to think, feel, and function every day. Don't forget, your brain is only as good as the blood that feeds it, so keep that circulation flowing. If you found this video helpful, check out more engaging content on King of the Curve, and make sure to subscribe, like, and hit the notification bell to stay updated. And see you in the next video.